Thank you. I'm Yoyu. I run a very small game studio based in London. And today I'm going to share our learnings on how to use cloud-native technology for game development in the past few years. Sadly, I don't have 17 years of experience to share, but please do ask questions because we have plenty enough time. We have a relatively small crowd, so please do interrupt me at any time if you have questions. So I actually didn't expect the previous speaker to take you to Colombia, Iceland, and so on. So I just came back from the Grand Canyon in the US on Sunday. So if you find myself mumbling, I will blame the jet lag. So I have a quite adventurous career as well. I started working in games about 15 years ago as a board game publisher. And I grew the team to over 100 employees and eventually sold the company. Around 2013, 2014, because that time, if you remember, everyone was doing a tech startup. So I was fortunate enough to join a tech startup founded by some friends. That's where I learned about the cloud technology. The startup didn't take off, but I went on working with some big consulting companies and advising on cloud technology for some multinational companies. Today, I'm still a Google developer expert for Google Cloud. And in 2020, during the Great Resignation, I quit my job to become an indie game developer. So that's probably the worst career decision I ever made. It's just a joke. Enjoyed every day working in indie games. Actually, I found it's very funny that the indie sticker, the icon of the indie sticker seems to be like instant noodles. So I think that probably very accurately describes the social status of indie developers. So towards the end of last year, I have my first indie game published on Netflix, that is Rings 3 Kingdoms. At the same time, I'm also working on another multiplayer murder mystery game called Whispers in the West. This game combined my passion for board games and cloud technology. How to use cloud technology in game development. So I'm going to take you through some of my learnings through my practices and talking to other indie game teams later on. This will be a slightly technical talk, but I will try to make it as interesting as possible. So for the people just joined, if you have questions, feel free to ask at any time. I arranged the content in a level-up format, so we'll start from level 1. Hopefully that's a topic most of you are already familiar with, and then we will level up from there. So first of all, before we jump into the topic, maybe it's worth asking what does cloud native mean? So in a very short form, being cloud native means the transitioning from servers to services. So what does this mean? I know this room, most people are really young faces, but if some of you still remember in the old days when you need to transfer a file across to your friends or in your workplace, some of us used to have your own FTP servers, or you have to carry a USB stick around. But nowadays, no one or very few people do that anymore. We just instinctively go to Dropbox or Google Drive to share your files. So this is an example of how services changed our lives. And of course, there are more cloud-native services that we can use. For example, if you come from the world of Unity, you're probably very familiar with Plastic already. You're probably very familiar with Unity developer tools. Actually, it's called Unity Gaming Services now. Also, there are numerous data analytics tools, and you probably already familiar with Google Docs, Google Sheets. You're probably very familiar with GitHub. And if we talk about the public cloud space, there are object storage, there are databases, there are functions or containers as a service. We will go through some of them, and I will show you some examples of how to utilize them in a bit. So what's in there for you? So what are the benefits of using cloud-native services? I'm not going to bore you with some consulting sales pitch. I think in a very simple form, services, they are more reliable, and they require almost zero maintenance, which means if you go on a beach holiday and come back, and you should expect the service still running, it requires very little engineering hours to maintain those services. And it also supports a very high degree of automation. So basically, you can think like cloud services is you can do a mix match, you can make a pipeline and combine them together to suit your needs. And the good thing, like for small teams, is really most cases it doesn't cost much for small teams because most of the services they are charged based on usage. So since you're working on small projects, the chances the usage is quite low, so it really doesn't cost much for you to run. So without further ado, let's jump to level 1. Level 1, I'm going to talk about cloud-based services. So these are the software as a service. So basically, you consume the services as they are. So again, two services. Perhaps some of you are very familiar with already. If you haven't, and you work in the Unity space, I strongly recommend you to look them up. So first, Plastic Cloud, Plastic SM, and as some of you probably already know, it's a replacement for Unity Colab, and being phased in last year. It's a version, it's kind of the de facto version control tool for Unity at the moment. And like most version control tools, it supports branching, which means you can have your development branch, you can have your release branch, you can have your development experimental branch, or if you work in a larger team, maybe you have feature branches. So it allows you to work on multiple branches at the same time, and it's really essential for collaboration. And even if you are a solo dev, I believe having a branch structure can improve your productivity as well. And Unity Cloud Build, part of the Unity gaming services. Personally, I think it's probably the most useful service as part of the Unity gaming services package. So basically, it allows you to build for multiple devices at once and remotely. So you don't build on your local computer, you build on the cloud build remote runners. So how it works, it pulls your Unity project files from usually the Plastic repository, and when it is triggered, you can configure it as automatic triggered. For example, whenever there's a change, it automatically triggers the build process, and it just builds like multiple versions for different devices at the same time. For example, you can build for Mac, PC, and mobile at the same time. So so Plastic and Unity Cloud Build are two really good services if you work with Unity. And if you haven't started using them, definitely check it out. And in relation to design, I want to share my experience of having game design specifications in Google Sheets. And again, I think probably many developers have already started doing this. So in the previous game, I worked on Rings 3 Kingdoms. Rings is a notoriously adopter of Google Sheets. So for people who don't know Rings, basically it's a Tinder-like narrative game. You swipe left and right to make decisions. And every card has a condition. Every card is selected based on certain conditions. So every card has text and its conditions. So because I don't want to go through developer PR for this talk, so I'm not going to show you the actual content of the spreadsheet. But if you are interested in, if you are curious, you can look up for Francois, so the original designer of Rings. He did a GDC talk in 2017 about how the Rings spreadsheet works. So the benefit of having your game design specification, no matter it's texts or stats in Google Sheets, is first, it's the user experience is probably much better than having it in other formats, for example, in Unity directly. And second, it separates your design workflow and your game logic workflow, so it's a little bit clearer to work with. And the most importantly, I think for a lot of teams, they choose this format is it's really easy for collaboration, because Google Sheets, as you know it, it's a web-based service. If one person makes change, everyone else gets a change automatically, and you can add comments in the sheets as well. You can see, I believe currently you can see the different versions for each cell even, so it's really useful in actual work. And next, I can show you a concrete example of the sheet we use in Whispers in the West. So on the left-hand side is a very, very simple example of a sheet data. Basically, it's there are some characters defined in the sheet. You can see the display name and the description for each character. So you can imagine in the actual game, whenever you want to have the character description, it loads directly from the Google Sheet. And how we do it is basically, it's quite simple. There's a Google Sheets.NET SDK, which allows you to access the Google Sheets API in Unity. The benefit of doing so, obviously, is like I described before, whenever the writer makes a change in the sheet, it gets reflected in the game. But be careful, there is a catch. The catch is Google Sheets is really not intended for to be used as a game backend or data backend for your game. So you probably don't want to use this architecture in the actual build. It's okay to use it in your dev process, but it's probably not a good idea to use it for the live game. This is because Google Sheets has a quite low API limit. I don't remember exactly, but it's something like maybe 50 API requests per minute. So as you can imagine, if you got loads of players, it probably will not satisfy your needs. So don't use this in the actual game. And as most cloud services, one of the challenge to get this work is get through the authentication. And authentication is a security feature. Basically, you need to tell the API who you are and whether you have access to the data. In general, there are two ways of authentication for Google Sheets API. You can authenticate as a user, for example, yourself, or you can be authenticated as a service account. A service account is basically a non-user account. A lot of tutorials on the internet will tell you to authenticate as yourself. In fact, I don't personally recommend that, because when you authenticate as yourself, you basically give the program application access to all your Google Drive data. Even if it's your personal project, it's probably not the best thing to do. So if you use service accounts, that will make the permission management much more granular. I actually have a secret YouTube channel, which is probably no longer a secret now. So specifically talk about how to do the service account authentication for Google Sheets API. And this code snippet is everything you need to actually get Google Sheets working with Unity. And as you can see, it's quite simple. The most difficult part is perhaps actually get the dependency installed in Unity. But once you get that in Unity, all you need to do is create a service account in Google Cloud Console and share the sheet with the service account. The service account is usually an email address. And you share the sheet with the service account as if you are sharing with the user. And when you create the service account, you also have the private key for the service account. You can load them in Unity as a text asset. And you pass the ID of the sheet you want to access, the service account ID and your private key, and then you can initialize the Google Sheet client. So that is level 1. Can I have a show of hands if you are still listening? How many of you are already at level 1? That's quite a few of you. That's reassuring. So you probably expect something more exciting. So can I interest you with some cloud-based task runners? So in level 1, I'm going to talk about cloud-based task runners. So far, we have mentioned the word automation quite a few times. And this is indeed a recurring topic when we talk about cloud native development. This is because in an ideal world, you shouldn't really do any repetitive tasks manually. If you find yourself repeat something, you should probably consider to automate it. And because automating tasks not only save you time, it also reduces the chance of making mistakes. But I understand totally, like in a small team, we need to constantly balance how much you want to automate and how much flexibility you want to keep within the team. It's not always easy to set up, and what is more difficult is actually maintain all your automation pipelines. So this is where I think something like a micro automation makes sense. What I call micro automation will be like specific tasks that automates very like certain automation that performs specific tasks. So GitHub Actions is a great tool to do that. But I should mention that GitHub Action is just one product in this big category of workflow automation tools. There are many tools similar to GitHub Actions, and the underlying technology is quite similar as well. Even the way how it works, how you use them, quite similar as well. I just use GitHub Actions as an example. So unlike in Unity, using GitHub Actions allows you to use some high-level scripting languages like JavaScript or Python. So it should be much more efficient than writing C# code because it's much more high-level language. And you can also integrate your workflow with a range of other services. And for example, you can integrate Google Sheets, you can integrate Discord. This example is how Whispers in the West, one of the workflows for Whispers in the West. So for Whispers in the West, and it's a narrative game, and we have the game scripts stored in different GitHub repositories. And whenever the writer makes changes to a repository, it checks the format for these scripts directly and gives the writer some feedback if there are any suggestions. And it also uses Google Sheets API to load in some metadata. So for example, it could check things like if the name of this item is correctly spelled, and it will check if the character used in the game is actually defined in the sheet. So it will check things like this. GitHub Actions automatically converts them into the data format, CSV or JSON, that is being used in the game. And we also have a little Discord notification in the end. Okay, this script has finished processing, so it can be this kind of little things can be quite useful in the day-to-day work. So for those who haven't used the GitHub Actions before, this is a simple example of workflow definition. I call it simple example, but we actually don't have anything more complicated than this in our actual work either, because it's really just really easy to set up. So this is the workflow to update the shared data used in our game. So it's all this kind of workflow tools that use a technology called Docker or containerization under the hood. So it runs on a virtual machine based on Ubuntu, so it's a Linux system. And you can see there are multiple steps. The first step says uses this actions, blah, blah. This is basically kind of like an official GitHub repository that allows you to check out some files. And then the next step is uses setup node, that is basically set up the Node.js environment. And all the like run or things like run is basically the Linux command we want this workflow to run. For example, install the Node.js dependencies and run the actual script that is tasked to update the shared data. And the last step you can see is actually uses action Discord. It basically pulls a third-party repository. This repository, someone else already made this repository, and we can just take it and use it to send the Discord notification. So apart from passing, all we need to do is just pass the URL of our Discord webhook, and that is done. So it's really quite easy to use, and a very important thing I want to mention about automation is always remember the human factor, because you can have, it doesn't matter how beautiful your automation pipeline is, if what matters is the users can actually benefit from it. And there are some little things we can do. For example, give the writers feedback. This is a screenshot, actual screenshot from our of the feedback from our workflow. So for example, in the game script, there's a line is too long. We just give the user this feedback. Okay, this line is too long. You may want to reduce it. Something as simple as this is actually immensely helpful for writers or users. And in Rings, I did something similar, like for myself and for the team as well. So in the latest version of Rings, we have a quest system. And as you guys all play games, a quest has a start, has an end, and has some definitions. But with the latest Rings, we have more than 3,000 nodes, and there are nearly 100 different quests. So it's very difficult to manually keep track of all the quests to make sure all the quests have been written properly. So I had this micro automation task, basically just check every quest does it have an end, does it have a start, and is it defined in the metadata. So this is very useful because every time I make a change, I run this workflow is run automatically. So I have the peace of mind knowing if I have missed something or not. So little things like this, maybe not super fancy, but it's really useful for writers or people who actually work on the project. So that is level 2. So I just talked about GitHub Actions in level 2. So In level 3, I'm going to talk about object storage. And so far, we have been mostly talking about consuming services as they are. So in this level, we are going to move to public cloud. So if consuming services as they are is like ordering takeaways, public cloud is like gathering your own ingredients and cook your own meal yourself. So there will be a little bit learning curve, but really not so much. And it's really, in general, it's really easy to get started. The most popular object storage services, I think, are AWS S3 and Google Cloud Storage. Some of you probably already used it before. For those have not, they are essentially like an advanced version of Dropbox or Google Drive, but they are more programmable. They are more APIs, and they are cheaper, they're potentially cheaper, and they are suitable for production use. So what can we use object storage for? There may be some scenarios that you want the players to update the game without actually updating you want the game to be updated without the player needing to actually update the game. Or you want to push a little change to your game, but without the need to actually build this game and release it on whatever store you use again. So there are times that you want to have essentially dynamic game content. This technique, I believe, is actually quite commonly used for bigger studios and especially like free-to-play games. So you want to be able to update some game content dynamically, and cloud storage is a really good tool for that. We mentioned before, like with Google Sheets is not really suitable for this kind of use case because you can't really, it has a very low API limit. It's not supposed to be used as a backend for production. So, but cloud storage is made for this. So how it works is really similar to how the Google Sheets API work. You can have your assets. You can upload your assets in cloud storage and then use the cloud storage.net SDK to connect to the cloud storage API and load the game when the game load the content when the game runs. Oh, okay. So in Whispers Invest, we actually took this recipe one step further because we want to offer the game content as DLCs, and we also want players to be able to share this content with their players. So how we do it is essentially we use the encryption and the decryption feature of cloud storage. So we upload the encrypted content in cloud storage. When the player purchases the DLC, they basically, all the DLC consists of is an decryption key. So they will be able to decrypt the dynamic game content from cloud storage with this key. And similarly, when they share the content, when they want to share the content with their friends, they can simply share this decryption key. And all this is actually yeah. I think there's a little bit lag in the, okay. Yeah, so all this is done within the cloud storage. So that is level 3. So we talk about object storage, and the most popular ones are AWS 3 and the Google Cloud Storage. It's in the public cloud, but it's really an easy place to get started. In level 4, we are going to talk about more cloud-based services. So one obvious recipe, like when we talk about cloud-native services, is cloud-native databases. When I talk to different small teams, I think many developers still quite hesitant about introducing any network component such as databases in their game, especially if it's a single-player game. Even for something as simple as a high score table, because their perception of the database is, oh, this is something going to break. I think people have this impression probably because when we learn databases, most people start from MySQL. MySQL is still great for specific purposes, but there are many more modern cloud-native databases that are much more reliable and much more easier to use than MySQL. So if you are building something new today, my advice is always check out cloud-native databases before you considering host your own database. Well, even MySQL, there are options to have, there are hosted options now. So, yeah, for cloud-native databases, Amazon DynamoDB is a really popular one, and AWS GameTech actually already written a lot of articles about the gaming use cases and design patterns for DynamoDB. So if you are interested, check them out. I'm not going to repeat some of the cases. In Google Cloud, the Firebase is a really popular product as well. For those who don't know, Firebase is more than just a database. It also allows you to host the websites, have like cloud functions, things like that. One of our developers actually did something really interesting with Firebase over the Christmas period. And I don't know if we can play this video. I don't know if someone can click on the video here. Yeah. So what he wanted to experiment is to build a Twitch extension that allows two-way communication between the Twitch viewers and the game streamer. So essentially, the game streamer can pull this Christmas cracker from in the game built in Unity, whereas the viewer from Twitch can use the Twitch extension overlay to interact with this streamer. So yeah, it's quite interesting case to experiment. So he used the Firebase to build completely to build this Twitch extension. So how it works is he uses Firebase Cloud Functions. So Cloud Function belongs to a category of services called Functions as a Service. It basically allows you to focus only on the logic of your function. Basically, all you need to do is write your function, and you don't need to care about the rest of it. You don't need to care about how the functions are hosted, how the functions are triggered. You just write your logic in Cloud Functions, and it works. So he used Cloud Functions to make some API endpoints. So in Unity, when the streamer pulls the Christmas cracker from one end, it actually sends a Unity web request to the Cloud Function, and the Cloud Function change the state of this particular Christmas cracker in the real-time database. And on the Twitch extension end, it's the same. Twitch extension is basically a web interface that you can overlay on top of the streaming window, the video widget. So on the Twitch extension end, it's the same. When the viewer pulls the other end of the Christmas cracker, it sends a request to Firebase Cloud Functions. And yeah, it's quite simple. And the reason I want to mention the example is also because this developer actually previously had almost no experience working with cloud services or anything like this. But he just picked it up by himself, like in a week's time. He already made a quite interesting Twitch extension that has potential for other use cases. And that is the next I want to introduce maybe more services that potentially can change the way how we work. For example, they are translation services. Can you integrate translation services in your development workflow? Machine translation is getting better and better now. And obviously, for text-to-speech is another hotspot. The AI powered text-to-speech nowadays is getting more and more realistic. This is something we actually consider using ourselves. And I feel like I have to put the buzzword like OpenAI here. So I would not be surprised to see in the future more games utilize things like ChatGPT or AI-generated art, and they are all cloud-native services and potentially goes into your development pipeline. So that wraps up level 4, our philo level. So we talk about databases. We talk about functions as a service. That is the Firebase part. And we talk about some other cloud-based services that potentially can be used. So thank you for bearing with me for the past half an hour or so. I appreciate that not everyone is going to use all the recipes here, and it doesn't make sense. So I summarized the 2 takeaways. So if you forget about everything that has been said at this talk, maybe there are 2 things you can remember. First is, again, automation is great, and automation saves you time and reduce mistakes. So whenever you find yourself doing something repetitively, ask yourself, can you automate this? And there are a lot of services that can help you achieve your whatever you want to achieve. And the next one is, whenever, maybe not now, but whenever you want to have a networked feature in your game, the chances nowadays you don't need a server anymore, so don't be scared by the idea of, oh, I have a server, I have to maintain it. Okay, the servers may break for no apparent reason. I think, in cloud-native space, that is no longer a big concern anymore. So, but of course, there are use cases. It's still very difficult to get around without servers, but always consider if there's an option that get rid of servers next time when you think about something. Thank you. That's all my talk. Check out our game on Steam or on Netflix, and you can find me on Twitter or LinkedIn. And if you anything we can be of help, please get in touch. Thank you.
Thank you very much. Now is the time for a question round. Do we have any questions? Okay, I already see one hand up.
Thank you very much. Hello. I have a question about Firebase, actually, because the real-time database, the Firebase is not supported on all the platforms. So what I'm thinking of is the synchronization between online and offline mode, which Firebase supports pretty much, and it works fine. But since it's not portable between all of the platforms, I was also thinking about the AWS and maybe. And my question is there a good synchronization between the offline and online modes for those databases?
So Firebase is not supported by I think the exact wording on the Firebase documentation is it has iOS and Android SDK, and those are suitable for production use, but they don't advise you to use Firebase in production for other platforms such as PC and console. I actually asked exactly the same question to the to the product manager of the team, and the answer I got is it's not like they don't want to support other console or other platforms, but it's really just not highly enough on their priority list to work on. And specifically for like the offline and online mode, I honestly don't know. I don't know that level of details. Yeah, but I think it is a pity that the support for consoles or PC platforms are not their priority at the moment. And actually, exactly for this reason, for our game, we are using like the classic Google Cloud rather than Firebase. Yeah. Yeah, I think in terms of a classic Google Cloud, it's very similar to having AWS in Unity. The underlying technology is almost, from SDK perspective, it's almost the same. Yeah.
Okay, thank you. Are there any other questions? Okay, please.
I have a question about already made game. For example, we have deployed game and we want to switch to clouds. Is it possible? Is it like we should write it from scratch with thinking about this moving to the clouds, or it's possible to implement cloud services during the game already is done?
Yeah, definitely. I think, for example, one thing I personally advocate for is have like the automation tasks for specific tasks. For example, if you find yourself, for example, repetitively convert some assets from one format to another, you can have an automation task exactly for this purpose. It's very difficult to have like one big pipeline that automates everything and always works perfectly. I think it's a dream, but it's really difficult, especially for small teams, to do that. Bigger studios, they may have the whole team of support engineers just to maintain this pipeline, but I think it depends on the size of your team. It may not always be possible.
Thank you. Okay, I see another question.
1, 2, 3. Thank you for your talk. Did you have any performance issues with JSON or CSV for levels 1 and 2? And why there is no asset bundles, for example, in your pipelines?
You mean, have I had experienced any performance issue with using JSON
yes,
in
due
Unity?
to deserialization and so on.
Due to, sorry?
Deserialization of JSON files or CSV files, if they're big enough, obviously.
Yeah, I think as JSON or CSV, like you have to, if you want to load the data, you have to load them entirely in memory. So if there's any performance issue, that's probably the reason. Yeah, I think in rings, they have done some performance optimization for it, and I should have mentioned that, like, for example, I'm not personally a developer for rings, but I know for rings data, and obviously everything is in a big spreadsheet, it's probably a lot of data, they did convert the CSV data into script objects, so that perhaps helps with the memory issue. But I don't know for sure.
Thank you. Okay, any other questions? Okay, I don't see any hands coming up, so thanks once again for a great talk. Big round of applause.